Network Plus series, wiring distribution components. Well, I've been in the IT business for about 20 years now, and actually my entrance into networking came in kind of a weird angle. I was a studio musician and engineer, and so back in the day, back in the 80s, a lot of the studios, especially the large studios, had extremely elaborate racks of equipment and processors and distributors, compressors, limiters, and huge patch bays of cords in the back that would be connected and directed to different systems or different areas of the recording process. So getting into networking for me was a very natural type of thing. And I have several friends who kind of worked their way up through the ranks of networking, and they started out in a whole different area. They actually began running wires and running cabling in facilities. And a lot of people in the IT business actually started out and cut their teeth in this wiring deployment area. As a matter of fact, a lot of high-end engineers now are still responsible for that at the enterprise level. What we're going to look at in this nugget is we're going to look at some of the wiring components you need to know about as a networking professional and also for the Network Plus exam. Well, when you finish this CBT Nugget, you can tell your friends I'm not an electrician, but I play one on TV. We're going to start feeling like electricians as we look at several key knowledge areas here and wiring distribution components. We'll look at patch panels. We'll talk about the 66 and 110 block and its role in your network infrastructure. We'll define MDFs and IDFs. We'll look at the 25 pair. We'll define the demarc or the demarcation point and how smart jacks play into that. And then finally, talk about the importance of being able to verify your wiring from the demarcation point all the way back to the end user stations. Okay, what we're looking at right here is actually my lab rack at home. I've got my Cisco routers and my I've got a PIX firewall. I've got a Cisco adaptive security appliance in here. I've got several routers, a switch. I've got an IPS, an intrusion prevention sensor. Also got an access server and a frame relay switch here. So I've got a bunch of stuff that's all racked up in this rack. And this particular rack would be referred to as an IDF, or an intermediate distribution frame. In other words, typically this might show up, let's say, in a central office or a central office area, maybe a wiring closet or a server room, maybe on the customer premises, and this would uplink or connect to the main distribution frame, which would be a much larger room. Now, because of the proximity of these devices to one another and the proximity of these devices to I've got, let's say, I don't know, about 5 or 6. There's a laptop right up here, which I use as a management station, but going through this wall over here, and there's a hole, you can see some wires going through this wall. That's going to take you into my office where I've got 3 workstations, 3 servers, and a couple of laptops. Now, because of the proximity of these end stations to my IDF here, my intermediate distribution frame, I can basically plug all these devices directly into the switch here through, patch cables that, let's say, are 10 feet patch cables. That's not a problem. But in a small to medium-sized business or enterprise organization, I need to have some way to extend this and do it in a more organized fashion. And that's where a patch panel comes in. Now, I mentioned in the introduction that I was in the music business as a recording engineer for years. And the patch panels there are really quite similar in concept to the patch panels we have in networking. As a matter of fact, you find patch panels in all different types of disciplines and technologies. Of course, we're going to focus on a patch panel or patch bay in an IT environment. Now, in a larger networking environment, patch panels can actually be used to facilitate and offer a more convenient way for network technicians to quickly modify the path of signals. The switch ports that are mapped to these patch panel ports, but also to the areas of the building, for example, the different RJ45 jacks are located in conference rooms and offices and cubicles throughout the organization. So a patch panel is kind of a non-intelligent intermediate interface that helps extend the capabilities and extend the wiring while also making it easier to manage, troubleshoot, and create a cleaner environment in a switched and routing network. Typically you'll find these patch panels in wiring closets. A wiring closet like the one you just saw earlier, my closet, is a small room where you make connections for electrical and networking capabilities. Often the wiring closet will have not only the computer network intermediate racks, but it will also have your telephony equipment. It will also possibly be the demarcation point between your organization and your service provider or telco. In a large building or a campus, you'll have lots of wiring closets and lots of different ways to run cables. Let me pull up a diagram from earlier to show you where a patch panel kind of fits in to this wiring scheme. So here's our switch, or our multi-layer switch, and we'll talk about this device later on. But mapped from these switch ports to ports on the patch panel are short patch cables. Now these will typically be RJ45 jacks that plug into the switch port. But in the patch panel, you'll also have jacks here, but on the back side of the patch panel, which would be kind of looking at this side right here, you have bare wires that are wired in there. And so you have bare wires coming from the patch panel to often what's called a 66 block. Now a 66 block is what we call, there's several different terms for this. It's called a punch block or a punch down block. It's even called a quick connect block. And it's used in a wide variety of applications. It can be used for networking cabling, but it's more often used in telephony, because you're going to take these copper wires and you're going to punch them down into these slots on the 66 block. Now it can be a 66 block, or it can have more, and you use a punch tool or a punch down tool to punch these wires down firmly into the slot. These are a very quick and methodical way to connect wiring. You don't have any stripping, you don't have the insulation to strip off, you don't have any screws, you don't have to deal with any jacks, things like that. So a punch block could be used as a patch panel itself, or it can be used to kind of punch down your telephone lines, for example. The 66 block or M block is used in our telephone systems. You also have what's called a 110 block. The 110 block is often used in residential telephone. It's also used in category 5 cable systems like you would see in networking. So let's say this is a 110 block and we are connecting our category 5 cabling. On this end of this cable would be bare wire punched into this 110 block. This would be a drop cable that would run either up in the plenum space, it could run under the floor, it could be in a cable run that actually goes to the wall jack that's in the office or the conference room or the area of the building, the cubicle. Okay, and then of course from the wall jack, with its RJ45 male connector, it connects with a patch cable into your PC, laptop, or other device as well. Now here's a couple of pictures of 66 or M blocks, also 110 blocks. 66 blocks and 110 blocks are often used in telephony, which also surprises me because this isn't really a telephony exam. We are going to talk about IP telephony in general as far as having telephony sent over a packet switched network, but this is not a telephony type of exam. So these you typically see these in telephone connections, punching down telephone cables in your wires in a telephone system. And again, the 110 block is also a type of punch block that's used in structured cabling. If you're going to use a 110 block in a computer network, it's often used at both ends of a category 5 cable. So in that previous diagram, that would probably be a 110 block where it's terminating Cat 5 cable that's running through the buildings, for example. Let me show you a picture of a 110 block and the tools you would use to terminate the Ethernet cabling. Here's an example of what I was talking about earlier, why you would use a 66 block or a 110 block here. And so here's our block. and you can see where we're punching down with here's where we're punching the wires down into the block. This is our punch down tool that we use. Of course, this cable right here will run through some type of conduit, either above the dropped ceiling or the raised floor, or through a cable run, and of course into these panels, which will be in your cubicles, in your offices, in your conference room, throughout your building or your facility. Next, let's go ahead and elaborate on the concept of IDFs and MDFs, beginning with MDFs first. An MDF is a main distribution frame, and this is typically a large cable rack or a cabinet. And this is what interconnects and manages the wiring between itself, the MDF, for example, that you might find in a data center or a server room, and multiple IDFs that you might find in wiring closets or server rooms on individual floors of a building, different areas of a building, different areas of a campus. So the IDFs actually connect the internal lines to the MDF. So the IDF has the connectivity to the smaller switch blocks and patch panels and cabling to the end user, where the IDF connects uplinks to the MDF. The MDF will connect the public or the private lines that are coming into the organization to the internal network. A MDF has a much higher capacity than a single patch panel, and often the patch panel itself can be built into the cabinet or the frame itself. Most MDFs are long steel racks or cabinets that are accessible from both sides. An IDF, like for example my rack that you saw, can be considered an IDF, but IDFs are also wall-mounted units. They're boxes. As a matter of fact, my particular rack was a 10-foot high rack that I actually had it welded down to make it shorter because it wouldn't quite fit in my closet. Let me show you a couple of pictures here. This right here would be the MDF, the main distribution frame, a series of racks that are accessible from both sides. It can also be cabinets, so this really constitutes a main distribution frame in a data center. This is more typical of an independent distribution frame, kind of a wall-mounted box. It may be accessible from both sides. So again, this could be a box or mounted on the wall. It could be sitting up on a table. It could be a rack itself. So MDFs and IDFs. Bottom line is you'll have a bunch of IDFs like this that are going to connect to a central MDF or main distribution frame, which will then go to the outside of your company, to the internet provider, the ISP, or some other service providers. The next concept that you want to know about for the exam is what's called 25 pair, the 25 pair color code. Don't worry, you don't have to memorize this, but you do want to know that the 25 pair color code is used to identify these conductors, these wires in your telecommunication wiring for indoor use. This is our twisted pair cable. You can see here there's a single core 25 pair 50 conductor cable that we're looking at right here. Here's a chart of how those twisted pairs can be grouped up. These can be used for common analog telephone service, as well as other twisted pair wiring conventions. The next concept we want to explore is the demarcation point, or the demarc. And historically, I'll start here at the bottom bullet point. Historically, this was used with the telephone company. It was a simple junction box that was basically where the customer connected to the telephone company's equipment. You very likely have a demarc or a demarcation point on your home, outside where your telephone company connects, your cable company, your DSL connection, your satellite. It's basically the point at which the facility or the campus customer equipment ends and where the telco or the service provider's equipment begins, okay? So that's the separation, the demarcation point. And it can also refer to a boundary of service level agreement responsibility. Depending upon how much money you pay a service provider, they may place their equipment on your site. If they did that, that would kind of move the demarcation point deeper into your organization. Or you could lease equipment at their site, which would basically move the demarcation point to their central office or their local loop. So it can be a physical demarcation boundary. It can also be kind of a contractual boundary of responsibility based on your agreement, your service agreement with your vendor or your provider. At your organization, one of the things that may dictate the demarcation point is basically what is the perimeter CPE. So what is the perimeter customer premises equipment, CPE? And this might be a modem. Historically, it could be an ISDN modem or a module and a router. It could be a serial connection at your organization. It could be a modular router, for example. Your modular router or your security appliance may have gigabit Ethernet or fiber ports on it, and those ports can connect to what we would call the demarcation point. A demarc is also known as a DMARC or an MPOE. MPOE stands for minimum point of entry. Another term that CompTIA wants you to know as part of this section is what's known as a smart jack. And basically a smart jack relates to the demarcation point. A smart jack is an NID. Okay? It's a network interface device. It is the demarcation point between the carrier's local loop and the customer's network, the CPE. So the term smart jack and network interface unit, NIU, is what connects you to the NID, the network interface device. Basically, a smart jack performs interface functions. It can do protocol conversion, code conversion, buffering. Okay, so this network interface serves as the demarcation point between the end user's inside wiring and the local access carrier's facility, for example, your telco. Now, the last concept that's on the bullet points of the requirements for this nugget is talking about being able to validate wiring. And this is more of just a goal for the networking technician, and that is making sure that you understand the types of wiring and cabling that's being used in your organization. You don't want to be too heavily dependent upon connectors. You want to know the wiring scheme of those particular wires. You want to know how they connect at every point in the organization up to the demarcation point. So the demarcation point is not only something that relates to maybe your agreement with your provider, but it also relates to everything from the demarcation point and then back into your organization, back into the building, into the facility. Any type of structured cabling or wiring or connectivity, you need to have an intimate and granular understanding at every point, all the way to the point where your end user workstations and laptops, okay, connect to the jacks in the cubicles or in the offices. So you need to understand that entire channel path from end user all the way to the demarcation point. And that is most likely going to be your responsibility. That may be the responsibility, as a matter of fact, of kind of entry-level network technicians. So if you're new in this industry, you may have to start out kind of at that level, laying cable, running cable, learning how to use punch downs, and stripping away cable, and understanding the wiring schemes before you can actually move up to get your hands on the network devices, the routers, the switches, the firewalls, the IDS systems, and the other applications and protocols and services that are used in internetworking. I'm not saying that that's necessarily the case, and I'm not trying to create some kind of class warfare here, but typically that is a entry point for a lot of network technicians. So the responsibility of understanding wiring and structured cabling may be extremely important to your future as a network engineer. Well, in this nugget on wiring distribution components, we covered several key knowledge areas. We talked about patch panels, kind of revisited where patch panels sit in the network infrastructure, looked at the 66 block and the 110 block and talked about their purposes. We defined MDFs and IDFs, also gave you a look at the 25 pair, talked about the demarcation point or demarc, and how smart jacks relate to that. And then finally, the importance of being able to verify your wiring from the demarcation point at your perimeter all the way through your network infrastructure to that end user workstation or laptop. Well, I hope this CBT Nugget has been informative for you. I want to thank you for viewing. We'll see you next time in the next nugget of the Network Plus